Hi, everyone. Welcome back to another science and technology session with Miss Hinkson. So, today we are looking at the lithosphere and its relief. We've been looking at the lithosphere. You've just finished learning about the rock cycle, which involves the lithosphere, right? Because the lithosphere is comprised of the Earth's the upper part of the mantle, right? The upper part of the mantle, and the Earth's crust, right? So all that solid stuff is what comprises the lithosphere. You guys, some of the stuff that we will be talking about today, almost 80% of the stuff, we've kind of touched on it when we were looking at the rock cycle, and you may have learned about relief in geography. So if you guys remember correctly, I show you this slide all the time because we are basically doing Earth system science. We are learning about the different spheres. So lithosphere involves solid Earth. Atmosphere involves the gases that surround the Earth. So anything to do with the air. And you've seen, we've talked about atmosphere when we were looking at the planets in the solar system, because we discussed which planets have an atmosphere, which ones don't. Atmosphere is that kind of envelope of gases that surround the planet. So you've already spoken about that. The biosphere is comprised of all life on Earth. So anything that's living organisms, you and I are part of the biosphere. Plants, animals are part of the biosphere. Anything that lives. And then there's the hydrosphere, which is comprised of anything that has to do with water. We mentioned that all these spheres, the world Earth cannot exist without one of these spheres. They are all connected in some way. We are part of the biosphere. We are living organisms, right? But we need the atmosphere, right? The gases that we breathe in we need that to survive. We need solid earth, the ground that we're standing on, the structures of our homes. All of this stuff is built with solid earth. And hydrosphere, we're made up of water, so much water, and we need water to survive. So every one of these systems is needed and they're all related. They all play a part in this cycle. So, relief, the evolution of the landscape. Relief is described as the shape of the Earth's surface. So, if you look at the globe, everything looks flat, right? If you have a globe at home, everything looks flat. We see green, we see blue. But if we really had a 3D picture of the Earth, we would see elevations, plateaus, and stuff like that. And everywhere would be different. There are no countries, no two continents or anything like that that have the same exact landscape. Things are different. Things are different because of human activity, what humans are doing, even the climate, right? So a place that has more water, that rains more, their landscape would look slightly different. Places that are dry, landscape looks different. So it's important to realize that the landscape of everywhere on this earth is different and unique. Okay, so these are some of the things I talked about. How do we describe the landscape of certain areas? We talk about, are there mountains? Are there hills? Are there plateaus? Are there plains? Is there bodies of water? Sea? These are the kinds of things that we would use to describe the landscape. So you guys have learned when we talked about the planets and we looked at Earth, Earth is in constant motion, right? When you sleep, the Earth is still moving. You wake up, the Earth is still rotating and revolving. The Earth is in constant motion. This we know. The motion is controlled by powerful forces. So we talked about that, the forces. We talked about forces even when we talked about gravity, and we also talked about this word forces when we talked about plate tectonics. So everything that is happening, all these cycles are somehow powered by forces. We talked about heat and pressure. Pressure is a force. So these forces come from the enormous heat and great pressure that exists under the Earth's surface. So we talked about heat and pressure, if you remember correctly. We talked about the Earth's core, which is very, very, very hot. And we have this understanding that when things heat up, they melt and they have fluidity, they move, and they're not solid. They're more or less in the liquid phase. But we discovered that the Earth's core is in fact solid. So we talked about why this happens. And we talked about the fact that there is great pressure. So while the particles want to move apart and be liquid and fluid, the great pressure compresses the particles of the molten rock and make it solid. So when we have high pressure, we can turn liquids into solid. So these phenomena cause the Earth's crust to fold over and rise up and fracture. Where have we heard this idea of fold over, rise up, and fracture? Give you a minute to think about it. So when we talked about plate tectonics and the different plates colliding, depending on if we have two continental plates, do they smash into each other? Does one subduct and go below? If they smash in together and they're almost of the same makeup and the same mass and they come at each other with the same force, not one is going to be stronger than the other, so they're not going to go down. It's going to go like that. And we talked about that when we talked about earthquakes, volcanoes, and the plate tectonics, or the tectonic plates. Again, the forces give the lithosphere its relief, mountains, valleys, plains, and more. And I'd like you to read this in the corner just to remind yourself often of what the lithosphere is. It's the rigid structure that comprises the Earth's crust and part of the upper mantle. The thickness of the lithosphere ranges from 70 kilometers beneath the oceans to 150 kilometers beneath the continents. So, how does the landscape change over time? How does it evolve? Winds, water, glaciers combine to alter the landscape of the Earth. This is no surprise to you because we talked about the effect of winds, water, glaciers, gravity, and whatnot when we talked about the rock cycle. I just wanted to point out your textbook will talk about erosion, but it will basically amalgamate or combine the idea of erosion and weathering into one thing. But you guys are aware that erosion, weathering, and deposition or sedimentation, these are three slightly different parts of a whole process. So we talked about erosion, and I wanted you to affiliate transportation or movement with erosion. So we talk about winds, water, and glaciers being responsible for erosion, which is the movement of the particles from one place to another. We talked about weathering. Weathering is the degrading or breaking down of the of the rocks, right? So degradation or breaking down by wind, water, glaciers. And deposition or sedimentation is the deposit, right? The laying down. So these are slightly different, but they all involve the same process, just different parts of it. So we know that humans play a very big role in the relief. How does our landscape look in our cities, in our countries? I grew up in the same neighborhood that I'm living in now, and it looks very different from when I grew up because there's a lot more of the trees have been taken down, a lot more condos have been built. The open fields that we used to have are now there's buildings there. So humans are responsible for changing the relief. You know, we add roads in different places. Um, and for the most part, we do negative things and change the relief. Yes, we have growing populations and we need homes to accommodate that. But we also do some good things. I've had neighbors who've planted trees when they first moved, and now the trees are big, and those trees were not there when I was younger. And when I looked into the history of where I live before our houses were built, it was actually a golf course. So somebody from hundreds of years ago, if they were to come back and see our neighborhood, it would be unrecognizable to them. So again, humans construct roads, dig mines, build cities and towns, etc. So what are mountains? We use words, all the time, and we're not 100% sure on the exact definition. We just use them. So mountains and hills, these are two things you would talk about, and you basically know the difference between the mountains and hills because you just kind of know it. But there's actually definitions that will help you compare the two. So, a mountain is a landform that rises prominently above its surroundings, generally exhibiting steep slopes, right? So, steep, right? That's that really, that incline like that. If it were something like this, that's not steep. That's steep, right? Try climbing a steep mountain. Try climbing a hill that's not that steep, right? There's differences there. And relatively confined summit area and considerable local relief. Okay. Now, one thing is if you had to differentiate, like if you're on a test, you were told about a land mass that rises prominently above its surroundings, and you had to decide whether it's a mountain or a hill, there are things to look for. But most importantly, the altitude of a mountain is at least 600 meters, which is very, very high, right? So the altitude, how high above the ground, 600 meters. Now, the reality of it is, if something is 599 meters, am I going to say, oh, it's not a mountain because it's 1 meter short of 600 meters? Probably not. I'll still call it a mountain. Okay, so mountain formation. We talked about this when we talked about volcanoes. What is mountain formation? What do you think that's happening? How do you think mountains are formed? Do you think this is something that happens overnight, over time? These are things for you to think about. So, orogenesis is the process of mountain formation. You probably never heard that word because nobody is talking about orogenesis over Sunday dinner, right? But that's what the scientific term for it is. Again, how do you think mountains formed? Is there anything that we've talked about or studied that can give you an idea of that? I'll let you think. We've talked about it about 3 slides ago. So when two continental plates collide, the Earth's crust warps. It folds over and lifts. In doing so, it creates mountain chains. So that's several mountains, right? So where the plates collide, because they're huge plates, right? And because if you had a smaller plate and a bigger plate and they smash in together, this big plate would win and this would just crumble or go below. But because the plates are the same class, they're relatively the same size, they come at each other at the same force, and they're not one gives, right? So they go like this and they smash and it goes up. We just talked about that. And that's the image over there. We see the plates colliding, and here is a mountain forming. And again, this is not something that happens overnight, right? These are lengthy processes. Same thing with the relief. The landscape of a place is something that's ever evolving, and it's not something that you will go to sleep unless it's human activity. You're not going to go to sleep and realize, oh, my landscape has changed around my house. Absolutely not. It evolves over time. So that's why it's great to look at pictures and look at how the landscape has changed in different areas. So now it's time to test yourself on the stuff that we've just looked at. So hill versus a mountain. How do you tell the difference between a mountain and a hill? If you had a landmass that's prominently above the ground and I asked you, tell me, what is this a mountain or a hill? List the characteristics that give you the answer. What are you going to say? Give you time to think about it while I drink my tea. Have you thought about it? Right. So a mountain has steep slopes, right? So steep, not like this, like that. It's very hard to climb. And an altitude of at least 600 meters. Hill is smaller and their summits, the top parts are a little bit more rounded and not as pointy as a mountain. So mountain versus volcano. What's the difference between these two? they're prominently above the ground, both of them, right? Formed by plates colliding. So how do you tell the difference between a mountain and a volcano? I think that's pretty obvious. A mountain is formed when the Earth's crust folds and rises. A volcano forms when magma reaches the Earth's surface and flows in the form of lava. Right? So that mountain, there's no magma coming up from below the Earth's surface, and then obviously when it comes up and it's outside, it's now called lava. But that's the difference between a mountain and a volcano. So plate tectonics and mountain formation. So what is the relationship between plate tectonics and mountain formation? You see that image below. The plate tectonics collide, right? And the Earth's crust folds over, and then we have a mountain forming. So again, when two plates collide, the Earth's crust can fold, mountains surge out of the ground. This is what happens when two continental plates collide. So erosion and weathering, we're going to talk about this again. By now, you're an erosion and weathering expert. And again, I'm going to remind you that when I send you to your textbook to read, I remind you that the textbook uses the word erosion to encompass basically erosion and weathering. All right, so erosion and the Earth's landscape. So rocks don't last forever. And when we talk about rocks, we talk about those bigger masses, right? Like a rock. They don't last forever in that form, because remember the rock cycle, there's just constant breaking down, amalgamating, heat, being subjected to heat and pressure, being subjected to water. And so, yes, the starting components, right, the contents of the rocks last forever, but the rock in its initial form does not last forever. Under the effects of wind, water, and ice, they wear down and break up. Erosion weakens and weathers rocks. Rock fragments can remain in place or transported by glaciers, winds, and streams. They are deposited in the form of sediment. Erosion results in flattening landforms. Okay, so we talked about this again when we talk about all this erosion, weathering, deposition, and sedimentation. What rocks were we talking about when we referred to these processes? I'll give you time to think about. There were three classes of rocks: igneous, metamorphic, and sedimentary. Which rocks would involve erosion? Yes, it would involve erosion, weathering, deposition, or sedimentation. Have you thought about it yet? I'll give you some time. So yeah, the sedimentary rocks, right? When we talked about how they are formed, we talked about the idea that there is degradation or weathering, the erosion. So there's the carrying of the rock fragments of the sediments. They reach their final destination and they're deposited below the bodies of water or wherever they land, and that's deposition. So yes, we talked about this when we talked about sedimentary rocks. So this section that we are now in is going to be very familiar to you. So you see this picture here is basically depicting how the relief has changed at some point. So maybe it was like this at some point, and then now it's like that. So we have some soil erosion happening, and just the landscape's very, very different. So again, you've seen this picture, and your textbook calls this stages of erosion, because I know we mentioned, okay, so erosion, again, transportation, weathering, breaking down, and sedimentation or deposition is the laying down or the depositing of those fragments. All of this would not be possible if there were not erosion, transportation. So it's in the transportation of the rock fragments and whatnot, they're coming across different landforms and land masses, and there's friction and there's wearing down. And then that friction and the wearing down is what weathering is. But if you're on a journey and there's transportation and movement, it eventually comes to an end when you reach a final destination or you stop moving, and that's deposition. So all of the stuff that's happening is dependent on the erosion, dependent on the movement of the masses or the rock fragments. So it's kind of hard to understand or see like, well, why are they calling it erosion? It's because erosion is like it's the main thing that's happening that is causing all the other things. If there were no movement of the fragments, there would be no friction, there would be no wearing down, there would be no deposition and layering and whatnot. There would be no sedimentation. So erosion is the foundation, is the key to all of this, the transportation. So weathering, surface materials fragment, right? So they fragment, degrade, or whatnot. That's why you get sediments. Transportation, the fragments are carried by water and wind, right? And when we talk about water, we will look at the hydrosphere. We're talking about H2O, but H2O can be in the form of a gas, could be in the form of a liquid, or it could be in the form of a solid. So when we talk about glaciers that are responsible for transportation as well, we are also talking about water, right? Sedimentation or deposition, fragments accumulate and are compacted, right? So they're laid down. So this is in your textbook. This is page 333. It's the stages of erosion. One, weathering, so the runoff and the freeze thaw cycle fragment surface rocks. Okay, so runoff and the freeze thaw cycle fragment surface rocks. Freeze thaw cycle is the idea that we have water on this earth, and when we are at the highest temperature during the day, that water is thawed out, it's in liquid form. And when we get to the lowest temperature, right, it's provided that it's near 0 degrees, we have frozen water. And as the temperature changes, there's this cycle of water going between freezing and thawing. Transportation, rock fragments are carried by runoff, water, and wind. Erosion is compounded by the abrasive power of fragments transported by the water. Sedimentation, at the end of the journey, the fragments suspend in water or transported by glaciers. Remember, glaciers are a frozen form of water, or wind accumulate and are compacted at the bottom of the ocean. They also accumulate in valleys and plains. Weathering comes about in different ways. The main agents of the fragmentation of surface materials are water, wind, and the freeze thaw cycle. Water can act in its liquid form or as ice or water vapor. Again, so this is in your textbook. So there are different categories of weathering, or your textbook will call it categories of erosion. There's biological weathering, mechanical weathering, and chemical weathering. And before I go to the slide that explains it, the differences, I'd like you to think about what these different things are. So what is biological weathering? What is bio? Think of biosphere, biological. What does that bio mean? Mechanical weathering. Where have you heard the word mechanical or mechanics? Chemical weathering. What are chemicals? What do they do? So, okay, so think about that. I'll give you about a minute. All right. Have you got your answers ready? All right, let's go on. So biological weathering is caused by living organisms, right? So when you hear biosphere, biological, you should think about living organisms, such as animals and plants. Mechanical weathering caused by variations in temperature and pressure, or wind and water. Chemical weathering caused by acid rain and pollutants in the air. So again, we see here, this is biological weathering, right? So we have the breaking down or degradation of this land mass, right? That's basically a rock by this tree. So the tree is growing up and separating that mountain. So it looks very different than how it would look before the tree began pushing out. So the tree is a part of the biosphere, it is a living thing, and it is weathering or degrading or breaking down this rock. So mechanical weathering. caused by the variations in temperature or pressure or wind and water. So if you think about the wind constantly moving the water and making it crash against the rocks, and the pressure on the rocks constantly over time, it's going to weather the rock. It's going to degrade it. It's going to break it down. It'll probably smoothen it because there will be friction repeatedly. Chemical erosion caused by acid and pollutants in the air. We all know that acid rain and pollutants. We know that these pollutants are strong chemicals. And for the most part, before we had such a great amount of pollution, there weren't that many pollutants. And acid rain, we're going to see what acid rain is and how that happens. It's really from pollution. So before, the levels of these dangerous pollutants and acid, the concentration wasn't very high, so that wasn't very dangerous. But now that we continue to damage the earth and put a lot more of these dangerous gases into the atmosphere because we have factories and stuff like that, they're coming back down onto the earth in the form of acid rain. We will talk about that. And you can see here, you can see that this this rock has been degraded or broken down or damaged, because you can see that, if you dropped chemicals on something and it kind of bubbles up and destroys it, you can see that that's what happened to this rock. Let me just drink some. I've been talking too much. I'm losing my voice. All right. So we're just going to look at this quick video.
Squeaks and I are getting ready to go on a hike, and today we're going to explore something big and old and beautiful. Do you know what I'm talking about? I'm talking about a mountain. We love climbing mountains, hiking through the mountains, and even just looking at them. That's an interesting question, Squeaks. How do mountains form? Well, let's start with what mountains are made of. Mountains are made of the same stuff that we're all standing on right now, the hard, rocky layer of the Earth's surface called the crust. Sounds kind of tasty, and that makes it easy to remember. The crust is the crispy, crunchy, rocky part of Earth. The dirt, the rocks, and all of the land on the planet are parts of the crust, and it covers the whole Earth, even the land that's underwater. So Earth's crust is kind of like bread crust. It covers everything in the same way that bread crust covers the whole loaf. But unlike bread crust, the Earth's crust isn't all in one piece. It's broken up into pieces called plates. Plates that cover Earth like a giant jigsaw puzzle. These plates are huge and heavy, but they don't just sit there. In fact, they're always moving. They move very slowly, just a tiny bit at a time, about a few centimeters a year. But over long periods of time, all of that moving around can add up to some big changes. Sometimes two of the plates in the Earth's crust will move towards each other, and when they do, they start to press against one another. But they have nowhere to go, so they'll just push and push against each other until they start to crumple. Then, the rocks that make up the plates are pushed up and over each other. The more they push together, the more the land rises. And after a while, voila, you have a mountain. And since the plates are so huge, when they push up against each other, they don't just make one mountain, they can make a whole mountain range. Mountain ranges like the Alps in Europe, the Andes in South America, and the Appalachians in the United States were all made this way by two plates of the Earth's crust slowly crashing into each other. But because the plates move so slowly, it takes a really, really long time for this to happen. I'm talking millions and millions of years. And you know what's even cooler? Some mountains are still growing. Mount Everest, the highest mountain on Earth, grows about 4 millimeters every year. And do you know why? It's because the two plates that make up the land in that part of the world are still slowly smashing into each other. That means that the mountain is just a teeny bit taller this year than it was last year. That's pretty amazing. So the plates of Earth's crust are always in motion, which means that a long, long time ago, the mountains we see today weren't there at all. Oh, and the Earth will look different in the future too, but it will take a really, really long time. So the next time you're walking around on a beautiful mountain, you'll know where it came from. Chances are it was made when pieces of the Earth's crust crashed into each other, and maybe they're still crashing. All this talk about mountains has made me ready to get out there and explore, so Squeaks and I are gonna hit the trails. But remember, if you have a question about anything you'd like to learn more about, just let us know by getting help from
So that completes our little lesson on the lithosphere and the relief. We'd like you to read pages 332 to 335. So I'd like to remind you what the lithosphere is. The lithosphere is the Earth's crust and the upper part of the mantle, right? So that's that solid part of the Earth, and it's responsible for what we see today, or the landscape that we see, and the forces such as the forces, heat and pressure, which fuel the rock cycle, right? And stuff that happens within our environment, such as the weather, right? So we have wind, we have water, we have gravity, we have water in its solid form, like glaciers and ice. All these things are working together to constantly evolve our landscape and change our landscape. So there is natural ways that our landscape is altered, but also don't forget the human aspect of that, that we humans have changed the landscape drastically, like when we cut down trees and build condos or build new houses, build new roads, build new cities. There are even new cities that have been built. So we play a role in the evolution of the landscape as well. I want you to remember the different types of weathering. We had biological weathering, mechanical weathering, and chemical weathering. Remember in your textbook, they refer to them as chemical erosion, biological erosion, and mechanical erosion. But remember, I want you to always separate the ideas of erosion, weathering, and sedimentation. Understand that they're a part of a bigger picture, but they each have, they each play their own role. Erosion gears the whole thing. It's the driving force because erosion is the transportation of the rock fragments using wind, water, or ice, right? So there's the transportation of the rock fragments, right? And then we have weathering, that's the degradation or the breakdown of the rock fragments using wind, water, or ice, right? So there's the breaking down, that's weathering. And then we have sedimentation or deposition, right? So erosion is doing this whole traveling thing. And as things are, the rock fragments are traveling, they're coming into contact with things, they're crashing into things. There's degradation, which is weathering, but it's a process, it's a movement, it's a journey, and it comes to an end. When does it come to an end? When there's a deposition, when there's sedimentation, when it's reached its final destination, when it stops movement and it's been laid down, right? So those are the three stages of erosion that your textbook describes. I would like you again to read these pages, and you have yourself a fantastic day. If you have any questions, please don't hesitate to email me at hinksons@loyola.ca. Again, that's HINKSONS at loyola.ca. You have yourself a fantastic day.